The CNC machine that I'm using is the Carvera Air. The software, the CAM software, is Makera CAM, so it is specifically designed for this machine or for that company. They do have a newer version coming out, which is all-inclusive, meaning it has the CAM software and the ability to connect to Carvera and send the G-code directly from the same software. But I'm going to use this one for now because it is what most people use in case you're using the same machine. Now, the elements that we'll go over are going to be similar to any standard CNC machine, meaning we'll cover how to do reliefs, how to do contours, how to select the tool that you want to use and the tool paths, and how to set the dimensions for your stock. Those are all going to be same, and they'll be universal no matter what CNC machine that you're using, especially if it's 3-axis. We're not going to talk about 4th axis right now. Most machines don't use that, and we don't need it for this project. So let's just stick with the basics of CAM that would be universal for any CNC machine. Let's start with how to set up your stock. So this is what we would be carving out of. We're going to be using aluminum. Let's go into Edit. You would set your dimensions, and I'll do this for you. Let's just do 200 millimeters by 150 and 1/4 inch thick, so 6.35 millimeters. That's what we're using for most of this project. And so that would set our stock. Notice up here it gives you the material. We're using aluminum on this, and that would set your stock. I'm going to go ahead and bring in or open a file that I've already used to build this project. And let's start off with something simple. So hit open. Don't save. So I saved a bunch from when I built this product. Let's just start with these lateral connections, very basic. Hit open. And you're going to notice that the dimensions that I originally set for this are there. And I just barely was able to fit in that lateral support. This is a small tabletop CNC. So I would encourage you to get a larger one, because then you could directly export out of Onshape the parts without having to slice them up. This one I didn't have to slice in half. It's its full length. But I did for the top frame, for the spars, for the legs. I had to quarter those up or cut them in half in order for those to fit on my CNC machine. It's a good skill to have in case that happens to you. Now you'll notice that the material thickness here are 3.17 millimeters. Down here, you're going to see all the different tool paths and the contours that I use. This doesn't require relief because it doesn't really have any shapes on top of it that needs to be cut out. It is the thickness of the material we have set here. We just need a contour, how to move stuff around. So you would have gone File, and you would go Import 3D Model. You go to your downloads, and then you would find that file that you exported, and you would select it. Let's just pretend we did that and it came in, but let's say we needed to move it. So we would left click on that, then right click, go to transform, and then move. And then this screen's going to come up. Hold down on the mouse wheel, that pulls that away. You have isometric view here, so you can move around the navigation cube just like you did in Onshape. And then you can right click on that to bring up anything that you want to do here to that part. So I'm going to left click on that, and you notice it gives you X, Y, and Z. You could scale it. So if you wanted to shrink it down, maybe it was past the border, it came in, it was too thick. Let's say we came over here and that did not match the limits of your stock. You could scale it down here in the Z, but you would need to turn X, Y, and Z off and just do it there so that it didn't scale the other parameters unless that's what you wanted. You can come up here and you can rotate it. So you can do that manually in isometric view, or you can go up to top view or any of the views. You could manually do it here with the mouse wheel. I don't want to move it right now because it's where we want it. And you could rotate it in X, Y, and Z. And you can also mirror image it. Those are probably the most common tools that you see there. We want it to be. We'll just do this one from the beginning. So left click, go up here to 3D path, left click on that, go down to contour, do anything. We're going to go to object, generate contour, and it makes an outline. That's what we want if we're just going to cut out the border. So left click on that line, you notice how it went to a dashed line. If that was going to go too deep, our end depth is what we have set here. We could change that. We don't need to. Let's just look at the most common tools here. Let's choose our tool. We're going to go to 3.175, 12 millimeters long, flat end for metal. So we're going to select that, and then we would select aluminum, which it automatically did for us. Sometimes it doesn't do that if you've been working on something different, and then choose. That's what I would normally use to cut something out. We will choose pocket, but later on, not right now. And then we're going to do outside. So we want it to cut the outside boundary. This is your tool right here, that diameter, and it shows you that it's going to be on the outside edge of this. Any of this is just the direction. Does it go from outside in? Does it cut across, parallel? Those are stock settings. Let's go ramping. So this is the plunge depth and the angle that it's going to plunge at into the material. How much distance do we have before it starts? And then when it pulls away, we're doing a 5-degree angle. And since we're cutting this out, we don't want it to fall out while we're cutting it out. We're going to do custom tabs. So I'm going to go down here and I'm going to do custom. I'm going to do add. I'm going to left click on that and I'll put enough tabs to prevent it from popping out. There we go. And then we could grind those off, but we can pop it out by hand. We hit calculate, and then it calculates that border. And you'll notice if I go down here along the edge, it's going to cut all the way from the top of it down to the bottom, leaving those tabs to hold it in. You can use double-sided tape if you don't want to use tabs and stick it to the surface of your CNC machine. But I prefer just to use tabs. All right, so that's a contour. That's how I cut out the lateral connections. Let's open up another one. Oh, while we're here, since we just did that contour, when you get ready to send it out to a machine, right click on that, go export. That's the one we just created. If you have multiple ones that you want to go with it, you can select them. You can turn those on. We don't want that because those were other parts we cut out. This is the part we just created, the contour. Hit export, and then you could name it. And I'm not going to name it because I've already done it. Oh no, these are the spar and leg connections. So these will be a little bit more complicated. So you can see we have the leg connections here. We've got the bolts that go through it. That's the one we redid. And the reason I said it's more complicated is because we have to do it as a relief and we have to do it as a contour to get all of it cut out. I do a relief first, and I'll show you that in just a second. These have to come in though. Let me go back up here. You can't do contour cuts on an STL file. It has to be a step file. So when I exported it from Onshape, where you saw STL, I just changed it to step, and that allows us to do the parts that a relief won't cut out. All right, let's just start here with spar connection. Let's left click on that. Let's go up to relief. And so what this is going to do is it's going to cut this part out, but we want to have a max depth. And so since I'm not going to put tabs on here, I'm going to stop it halfway because we'll use a contour to cut it the rest of the way out. So that's why you see a difference in the Z height here. So the full height of the stock material was 25.40. I stopped it early, so 25.200, so that we would still have material so it wouldn't fall out after the relief. I use this tool, just like I showed you how to select it before. I did step downs, so 0.200. So what that means is, how deep is that going to plunge with each pass? We don't want it to go too deep and break the bit, but this is what was recommended for aluminum. We've got model boundary automatically selected. All of this was automatically selected. Again, we're doing outside boundary, so it'll go around the outside of it and cut it completely out, except for that material I told it to stop at. We did ramping. So the ramping distance, I normally will do 10. Right here, somehow it changed to 0. It should have been 10. And then we would calculate it. And then I'm going to go over here to the side so that you can see what I was talking about where it would stop at. So right here, it's going to cut all the way down, but it's going to leave this material because I told it to stop early, because I wasn't able to put tabs in there with a relief. And so I don't want it cutting it completely out. At least on this machine, it won't let you. So there's our first relief. And that was the first step in cutting that out. Then I selected it again. I went contour, generate. Oops, I got to select it again. Generate. And now it's selected just that area. And this, for some reason, this machine has trouble in a relief cutting certain angles out. And it's probably the bit that I've chosen. It's not a ball end. It is a flat end. So we're going to select that. And then we'll go down here. So if you ever see something that's not cut out by relief, you can come back in and use this method to cut these parts out. You see how I'm highlighting these? Like right now we have this highlighted. I'm just going to do one at a time. You can come back and highlight this one and it'll cut it out a little bit better. When you have a curvature like this, you'll want to use a ball end bit. So anyway, you select this. We see the dashed line. We'll go down here and choose our tool. Select this tool. If you've got something that's curved, this is where that ball end would be really good. This will do everything we need. This 3.175, 12 millimeters long. So this is the diameter. 3.175 is the diameter of the bit. Pretty close to 1/8 of an inch. And then 12 millimeters is how long it is. Kind of like how you would read a bolt. We've got aluminum selected. We choose it. There's our tool. We got our step downs at 0.20. We're going to do inside on this one because we need it to do the inside portion of this. Ramping, so the angle and when it's going to start the plunge at 10 millimeters away and the angle that it's going to come in. And we don't want any custom tabs because it's not cutting anything out. We just want it to remove material, calculate. And there we go. So it's going to cut that portion out. So that's how you would do a face. I'm going to turn this one off. We're going to select this whole thing. We're going to come up and do a contour. We're going to do object, generate. We want to select these two holes we need to drill out. So I'm holding down the shift key. We see the dashed line. We come down. We're going to do a pocket so that it just drills those out. We're going to use the same tool. Now here's the deal. That 3.175, luckily these are 4 millimeters, so it'll fit down in there. But if the hole that you're trying to drill is smaller than your tool bit, it's not going to let you do it. So make sure the bit is smaller than the diameter that you're trying to drill. So we're doing pocket. ramping, calculate. So we'll wait for that other one, and then you would export that. And you can export these all together too. You can just do these and then export them. So that's a pocket. And then the last one we would have done on this, I'm going to go down and turn this off. You don't have to keep turning these off. You can leave them on, but for me, it distracts me. I want to see exactly what's getting cut out. So I'm going to left click that again. I'm going to come up, I'm going to go contour, and this would have been the final cutout. So we go to object, generate, select the outer border this time. If I can select it. Sorry, there we go. You got the dashed line. We'll come down. We don't want it to stop. We want it to go the full length here of the material. Choose. We're going to use that same bit. We don't want the pocket this time. Instead of inside, we're going to do outside on this contour. And this is going to be the final cutout. We want the ramping. There's the same settings. We want to do custom, just like we did on that other part. We'll do add. I want to make sure I place these. I don't want to place that tab anywhere. It could mess up something. I'm just going to place these over here on the side. That's plenty to hold this small part in. And calculate. And there's our contour. And then that will take it all the way down and cut it out, and you see the tab right there. Now the one thing that's different from that first part that I showed you when we did the tabs is the thickness of the material. So there's a lot it has to remove. And if you don't want your bit to go back through and waste all that time of it stepping down to get to that point, you notice here I set the start depth of that at 9 when I did this, so that it went all the way down, but it didn't have to go through all these motions where the relief had already cut it out. It started just above here, and then, but I didn't want to accidentally plunge too deep in the material, so I stopped it a little bit early, and then it goes in and it does the cutout. And that'll save you time, so you can always change the start depth if you've already removed material. All right, I've shown you pretty much every tool you're going to use for this activity. Relief to kind of cut it out and rough it out. Contour, but a contour face where you can cut individual faces that maybe didn't cut out very well on the relief. Contour object where you can either do a pocket and drill or cut the object completely out by the border of it. So when you do your contour, you're going to want to do all of this inner stuff itself. So you would do a contour cutout of these, pockets of these drill holes, pockets of that, and then the inner portion of this. But this is going to have to be part of your outer border when you cut these out. So you won't be able to do it at the same time you do these letters. But you can see how I had to split that frame up in quarters to get it to do. And now I did not have to do a relief on this. This is all contour. Same thing for that lateral support. It was all contour. Instead of 1/8 of an inch, you're going at 1/4 of an inch. But you don't need a relief on these. These are just contours. You contour the inside, pockets for the drill holes, and then contour the outside. That's how I had to cut up the spars. So if you now these were 1/8 of an inch. And then I did some other ones that were cut at different areas so that when they were welded together, the cut wouldn't be in the same portion. But if you were going to cut these out of 1/4 of an inch, because I welded 2/8 of an inch together to get 1/4 inch thick, because I found 1/8 of an inch was not thick enough. If you just cut this out of 1/4 inch material, you can just weld it here. 1/8 of an inch thick, pretty easy. Just contour pocket on the inside, contour with tabs on the outside to cut it out. So if you're just going to do a relief, you can get away with an STL. But if you're going to do a contour, especially if you need a contour face, it has to be a step. And that's how I placed them on the, and you can cut them out in one go. There's our swing arms. Let's do this one. So there's our contour. Let's go export. We've got it selected. Export here. Let's go lateral support video. So we know that's for the video. This is just a simple contour on the outside. I'm going to minimize this. And they've got a beta version of the software where these two are combined. So we go Wi-Fi. It's going to find Carvera. And this is what's going to be nice once they get the new software through beta, is you won't have to do this element. You won't have an extra piece of software. You go down here to open the G code. You go upload, lateral support NC. So you're looking for that NC. You see the MKC, don't try to open those, because that is the actual file where we were doing the CNC, and it will mess this software up sometimes. Hit upload, it'll try to upload it. You want the NC, the G code. It's going to upload. There it is. So this is the border. Then you would go over here. You would config. I'm just going to do the X offset at 1, Y offset at 1. We would do scan margin. I'm going to turn off Z probe. And instead of doing all those points, I would set it here. I would hit OK. And then I would hit run. I'm not going to do anything right now because I have something in there. And it would ask me if the probe was in. I'd hit OK. Then it would run that probe. It would check all these points that you see here. And then once it verifies that we've got the right stock in there with the laser probe, it comes back and asks if the appropriate tool is in there. You switch out the probe for the tool. You can either start it from the machine, or you can hit run again from right here, and it'll start running your CNC. So that's all there is to it, to CNC. Not much more difficult than 3D printing, just a couple extra steps. One, that you have to go in and set your stock. You don't do that in 3D printing. And the other, you have contours, you have reliefs, you're removing material, so it becomes a little bit more complicated with the tool paths. But as long as your software is good, it's not that complicated. If you can do 3D printing, the next step for you would be CNC.